should be recording now. So this is 2C question 8. The roots of 2x squared minus 3x minus 5 equals 0 are p and q. Find all quadratic equations with roots p squared plus q and q squared plus p. Now, I think I'm going to do this question in two ways. I'm looking at this quadratic and I'm thinking this is something that I could factorize using the AC method, where what we do is we say the AC term equals 2 times minus 5 is minus 10, and there's factors of minus 10 that I can use to split the middle term. So what I'm going to do is factorize it, because factorizing is an easy way to get at the roots, and then I could label one of those roots P, one of those roots Q, and I think it will be an easier way to do this question. But I will attempt to do it in two ways because I think the book wants me to do it a different way. So one of the roots here, right, when this quadratic equals 0, x would be minus 1. They've said we're going to label our roots p and q. And q, what do we have here? We'd have 2x minus 5 equals 0, so 2x equals positive 5, x equals 5 on 2. And we're going to call that root q. Now they've got new roots, so we've got, consider some different roots that we can build out of p and q. The roots were going to be p squared plus q and q squared plus p, and I can work that out, right? So I could say p squared plus q. See the symmetry in this. So it doesn't matter what I've labelled p and what I've labelled q. They're just two different roots. One of them's p squared, one of them's q squared. So it's going to work out, right? P squared would be minus 1 squared is 1 plus q. So that will be 7 on 2, right? Q squared plus p, that would be 5 on 2 squared. That's 25 on 4. Then I have to do plus p, so that's minus 1. I'm going to write the 1 as a 4 on 4, so I can do this fraction subtraction easily. Okay, now I can consider the sum and product of these new roots. So the sum would be 7 on 2 plus 21 on 4. Actually, I will write the 7 on 2. The 7 on 2 can be a 14 on 4, so it's easier to add up. All right, 14 plus 21, that makes 35 on 4. And that's our minus b on a. Okay, now the product, 7 on 2 times 21 on 4. So we're doing the product of the roots. 7 20s, 140, 717. So we've got 147 on 2 times 4 is 8. That's our C on 8. Now, our A's didn't match up, but I can easily make them match up. If I double this, 70 on 8, right? Okay, so we've got A is 8, a B is minus 70, a C is 147. So here's a quadratic, x squared minus 70x plus 147 equals 0. I'm just thinking of a further way we could have done this. We could have actually just gone straight to, if we'd done p squared plus q, found it out as a number, we could have turned it into a linear factor. Maybe I'll do this. If we had, I'm going to do this with simpler numbers. If we had some roots, let's say they're minus 2 and 4, we know that there's a quadratic that exists with these roots, x plus 2 x minus 4, right? Okay, so I could have actually worked out what those numbers were and slotted them in here. Then I could have expanded out the quadratic. Now there would have been fractions, but it doesn't matter. You would still have the same roots when it equals 0, right? Just in the same way as like if I took one of these and I said it's 2x plus 4, I mean it'll change the shape of the quadratic, but it won't change the x-intercepts, right? So when it equals 0, I still get x is minus 2, just like I do from that. And that sort of leads nicely on to this question. Asks for not just a quadratic. At the moment I've only got one quadratic. It asks for all quadratics. It's really easy to do all quadratics. All easy. You just multiply by some number, right? And it won't affect the roots. Right? It will affect the shape of the quadratic if you were graphing it. So it'll affect all the other values, but it's not going to affect when this equals 0, because you could divide by a on both sides. A can't equal 0, but a could equal positive number, negative number, a fraction, right? It can't equal 0 because if it equals 0, you don't have a quadratic anymore. You've just times the whole thing by 0, right? But it can equal any other number. Okay, I'm going to now try and do it the book's way. Well, what I assume is the book's way, based on their worked example that they had earlier on. So we're going to say, okay, we've got two roots, p plus q. The sum is minus b on a, and taken from this quadratic, that would mean 3 on 2. We've got two roots, the product pq, that equals c on a. Here that'd be minus 5 on 2. Okay. Now consider two new roots. Consider two new roots. The new roots are going to be p squared plus q and q squared plus p. All right. So let's look at the sum of these new roots. We get p squared plus q squared plus p plus q. Unfortunately, this being the last question in the chapter, this is not as straightforward as some of the other questions. I know what a p plus q is. It's 3 on 2, but I don't know what a p squared plus a q squared is. And if I want to stick to this method that I'm adopting here, I know what a p plus q all squared, p squared plus 2pq plus q squared, that's pretty close to p squared plus q squared, but we've got this extra bit here, right? So how about we take this and we change it to that one. We can say that p squared plus q squared is pretty similar to p plus q all squared, but we don't want to have this minus 2pq, and we want to keep the p plus q that we had here, right? So I know a p plus q is a 3 on 2, it's all squared, so that's a 9 on 4. Minus 2pq's, all right, so it's minus 2 times 5 is 10 on, so that'll be plus 5. Actually, let's write that as a on 4. Okay, so I've just done the 2pq, all right. There's my PQ there, so it was 10 on 2, that's 5, but then I'm making it out of 4 because I'm going to have to add everything up, and then we got another P on Q. A P on Q was a 3 on 2, but I'm going to make it 6 on 4 so I can add everything up, and I get 35 on 4. 9 plus 6, that's 15, plus 20, 35. And that's representing the minus b on a in the new quadratic. Okay, let's look at the product. So I might start up here. Product of p squared plus q and p plus q squared. That equals, we need to FOIL. We get p cubed. We get p squared q squared, which I'm actually okay with. The p cubed I'm not happy about at all. So that was outside. Inside, pq, and last is a q cubed. And there's a bit of a problem here with that and that. The p squared q squared is fine, right? So I know that pq equals minus 5 on 2. That's fine. I can square that and it's the same as what I've got there. Right. But how could I deal with the p cubed and the q cubed? I guess a similar way to what we ended up doing here, where we thought of it as a quadratic. Well, we thought of it as a perfect square. This is not a quadratic with cubes. I reckon, let's think of a factor p plus q. I think using that factor, how could we get the cubes? Well, probably just from this. I know I would at least get the p cubed and the q cubed, but I'm also going to get a pq squared and a qp squared. That's a q, that's a p squared. And I've got my q cubed. So that's looking okay. Over here equals p cubed plus, let's try take out a common factor here. We get q plus p. Now that is something I can work with. Alright, because I know what a pq is and I know what a q plus p is. So thinking this through, alright, my p cubed plus my q cubed equals that one. Right. This, it doesn't equal that. It equals that minus away this. Right. I reckon I know what a p squared plus q squared is, because we had to use that in the last one. Well, it's a bit of work though, isn't it? Wow, okay. So in the last one, the sum p squared plus q squared plus p plus q was 35 on 4. I know a p plus q equals a 3 on 2. All right, so given that a p squared plus q squared plus a 3 on 2, that's a 6 on 4, equaled 35 on 4. It means that the p squared plus the q squared equals 29 on 4. Right, so that could go in here. Okay, so that's 29 on 4. Then we'd have to remember that we have to minus this. All right. So there's a little bit of figuring out there. We could say the product is, right, now we've also got these. I might write these first. So the product is PQ all squared plus a PQ. Now it's plus P cubed plus Q cubed. I've changed that to P plus Q times P squared plus Q squared minus this one. Right. So this is a P plus Q times P squared plus Q squared, this is awfully long, minus a PQ times P plus Q. Wow, this is incredible. All right, so we've got minus 5 on 2 all squared plus minus 5 on 2 minus 5 on 2. Then we've got plus P plus Q. That's 3 on 2 times 29 on 4. So I worked that out before. Minus PQ, that was minus 5 on 2 times Q plus P is 3 on 2. Wowzers. All right. So what do we get now? We get 25 on 4. Now, actually, we're going to get, when we do this multiplication, we'll get everything on 8. So let's go for a denominator of 8 from the start. We'll have 25 on 4, that's 50 on 8, minus, to get that onto an 8 after times by 4, so it's minus 20 on 8, right, plus 3 29s, that's, what's that, 117. No, it's nowhere near that. My tired brain. Okay. Let me try that again. It's 87. All right. What do we got here? Minus, that's going to give 4. I think I might have to do this in 2 steps. We've got minus 15 on 4. Right, so it ends up with plus. Okay. And we need to double it, so we get 30 on 4. We're going to end up with plus 30 on 4. Sorry, 30 on 8. If we're doubling the 15, right? So we've got minus, minus, that made plus. 5 times 3 is 15. 2 times 2 is 4. So we have 15 on 4. We're doubling it to make 30 on 8. Now, adding all this up, I'm getting my product to be 50 minus 20 plus 30. What does that give? 30 plus 30, 60. 60 plus 87 is 147. Wow, that was a lot of work. That's the C on A. But it has worked because I remember that from the last one. We can write it up here, I think. I think now I'm actually starting to think the book didn't want you to do it that way. The A's 8. The B at the moment is minus 35 on 4, but remember we want to have the same A value, so we're going to multiply that up. So the B is a minus 70. The C is a 147. So we're going to get 8x squared minus 70x plus 147. Don't forget these are roots, so it equals 0. And because they wanted all quadratics, we're going to whack an A out the front, which stands for any number you like, but the A cannot equal 0. Okay. Thank you.